Hello. Today's first lesson will be about confidence intervals about a proportion. So here we have problem 1. 1 states a 2013 survey of 126 randomly selected United States citizens showed that 93 do not trust survey results. With a 90% level of confidence, construct a confidence interval about the population proportion of United States citizens who do not trust survey results. Before we get into any discussion as to how we approach confidence interval type of problems, we need to determine which is the correct sampling distribution that we use for these types of problems. We have two choices of sampling distributions. One is the standard normal distribution, and the other is the t-distribution. Since this problem is a problem where we're looking for a proportion, and we know that because of keywords, it says construct a confidence interval about the population proportion of. The rest doesn't matter as far as determining which would be the correct sampling distribution. If we're doing a problem that deals with proportion, we will always use the standard normal distribution. Also, we can call it the Z distribution. Problems that deal with means may or may not use the standard normal distribution. When we get to one of those, we'll discuss in detail whether we get to use the standard normal distribution or whether we have to use the other distribution that we'll be using called the t-distribution. Now that we know for the problem at hand that we're using the standard normal distribution, let's talk about the parameters that we need to look for. The first thing is x. X represents the number of those who responded favorably to the survey question. In other words, this question asked, do you trust surveys? And out of the total of 126 people, as it says in the problem right here, out of the 126 people, it said 93 people do not trust survey results. So 93 actually responded favorably that they do not trust survey results. Or should I say 93 of them explicitly stated that they do not trust survey results. N always represents a number of things or a number of people. And in this case, N represents the total number of people that were surveyed, which is 126 for this problem. We have this thing P with a little hat over it, and we pronounce that P hat. That represents the proportion of those in the survey that responded favorably to the way the question was asked. And P hat always equals the number of people who responded favorably divided by the total number of people that were asked the question in the survey. We have Q hat, and it's pronounced Q hat, and it represents the proportion of those in the survey that did not respond favorably to the way the question was asked. In order to get that number, we just subtract P hat from 1, or 1 minus P hat equals Q hat. Something that you should always remember in probability and statistics, that a Q is always equal to 1 minus P. The next thing that we're looking for is the Greek letter alpha, lowercase alpha. And that represents what we call the level of significance, or the area of error. Alpha is always the complement of the level of confidence to 100%. In other words, for this problem, since the level of confidence is 90% or 0.90, the level of significance is 100% minus 90% or 10%. But we typically write it as a decimal, so we would write it as alpha equals 1 minus my level of confidence, or in this case, 1 minus 0.90, which is equal to 0.10. It's also important to note that some of these problems won't even state a level of confidence or a level of significance. We have a default value for that. The default value for a level of confidence is always 95%. In other words, if there's no level of confidence or level of significance shown in a problem, we just use 95% for my level of confidence and 0.05 for my level of significance. So for this problem, since my alpha is 0.10, we're really concerned with half of that error in each tail. In other words, 0.05 would go to each tail. If alpha is 0.10, then alpha over 2 is 0.05. Next, we have this thing we call z sub alpha over 2. And that represents the z value that corresponds to the error area in the right tail. It must be a positive value. At least it needs to be a positive value for confidence intervals. In the future, we're going to talk about something called hypothesis testing. And in hypothesis testing problems, the z sub alpha over 2 could be positive or negative. But for confidence intervals, we always use the positive z value. So we're using the one that corresponds to the right tail. The only way to really find this is to look it up on a table or to use our spreadsheets, which is essentially looking it up in a table. And when we do that, for this problem, remember alpha over 2 is 0.05. And as you can see on the standard normal curve, we split that up into two tails. We have 0.05 on the right side and 0.05 on the left side. What we're looking for is this z value right down here. In other words, it's going to be between 1.5 and 2. So I'm not sure what it is yet. The only way we can do that, as I said, is to look it up on a spreadsheet. And when we go to spreadsheet mode, you'll see all of that and how I got that. So if I were to say I want you to do this right now, and we need to find the z value that corresponds to 0.05 in the right tail, we would type in on the spreadsheet equals norm.s.inv of 0.05, or whatever the cell reference is where the 0.05 is. And if we saw that, our result would be 1.645. So here's 1.5, 1.6, and 1.645. Looks like that's about right here. We would have a z of alpha over 2 of 1.645. Actually, when we put it into the function on the spreadsheet, we get the negative 1.645, but we actually need the positive value. So how do we always get a positive value out of that? We simply take the absolute value of our result. That will always give us the positive value. After we get the z sub alpha over 2, we have this somewhat complicated formula to calculate this thing called E. What we do with E, I'll explain that in a little bit, but we're almost done getting all of our parameters to get to our final answer. For this problem, we now have n is 126, that's given to you in the problem. X is 93, also given to us in the problem. We have p hat, which is 93 over 126, or approximately equal to 0.7381. Q hat is equal to 1 minus p hat, and in this case it's approximately equal to 0.2619. We take all of those things that we got, including the z sub alpha over 2 number, and we put it into this formula for E, and we get that result. After we get that result, the rest of this is very easy. In fact, the whole thing is easy because we'll end up doing this whole thing on a spreadsheet. E is equal to 1.645 times the square root of, this is p hat, 0.7381, times q hat, 0.2619, all over n. When I do the arithmetic, and remember that's all done on the spreadsheet, it's approximately equal to 0.0644. We're done with the hard part. That E gives me my error. And what I do with that error is I subtract it from p hat, get a result, and I add it to p hat, and I get another result. In other words, for this problem, on the left side, we would have 0.7381 minus 0.0644 is less than P, or the population proportion, which is less than 0.7381 plus 0.0644. When we do the simple arithmetic here and here, we get 0.6737 is less than P, which is less than 0.8025. What this means is that the population proportion is between 0.6737 and 0.8025. One of the biggest problems that students have in probability and statistics is interpreting what a result actually means. So let's backtrack a little bit. First, we took a survey. We had about 126 people in that survey, out of which 93 stated that they find surveys to be untrustworthy. We take that proportion, 93 divided by 126, and we ended up with a number, 0.7381. That number is what we call a point estimate of the population proportion, meaning that it's a single number, and that single number we can use as an estimate for the population proportion. We don't know how accurate that number is. Depending upon how big my sample is, it probably, can be more or less likely. When we find a confidence interval, we're picking a level of confidence, and we end up with a range of values. And that range of numbers, we can be confident that if I were to go out and survey the entire population under consideration, I can be, in this case, 90% confident that true population proportion of those who find surveys to be untrustworthy would be somewhere between 0.6737 and 0.8025. So how would we state that answer? How we would state it is like this. We can be 90% confident that the population proportion of those that find surveys to be untrustworthy is between 0.6737 and 0.8025. Let's go to spreadsheet mode and do this problem on a spreadsheet, because that will help us with the next few problems. Here I am in spreadsheet mode, and let's type in the stuff that we already know. The stuff that was basically just given to us in the problem. They gave us an X. Remember, that's the number of people who responded a certain way. So that was 93. Total number of people was 126. How did we get p hat from that? Well, p hat is going to equal 93 divided by 126. And that's where I got the 0.7381 number from. I rounded at the 10,000th place. How do I get Q hat now that I have P hat? Remember, Q is always 1 minus P. So I would type in equals 1 minus my P hat value. And that's where I got the 0.2619 number from. We let the spreadsheet do as much work as we can, and that's why I don't just type in the literal for Q hat. I type in a formula so that if these ever change in another problem, then that'll update my P hat and Q hat. And we can always use this spreadsheet when I'm talking about confidence intervals about a proportion. Next, we're talking about the level of confidence. If you remember from the problem, that was explicitly stated as a 90% level of confidence. On the spreadsheet, I'm going to type that in as 0.90, and you'll see it just automatically defaults to 0.9 because it's the same as 0.90. Alpha, remember, is the complement of the level of confidence. And that, just like a Q, is always a 1 minus a P. Alpha is always 1 minus my level of confidence expressed as a decimal. So we're going to type in equals 1 minus 0.9. Alpha over 2 is simply what it looks like. We divide alpha into 2. I would say equals. I click on the cell that contains my alpha value, and then I would do divided by 2 and enter. Z sub alpha over 2. Well, for that, remember, we use a special function built into spreadsheets. And that function is the norm.s.inv function. And you'll see what that looks like. Equals norm.s.inv, and then open parenthesis, and it's asking for the probability, which is what I call area. Remember, those are synonymous. Click on that, and then I close my parenthesis, and I press enter. Now that gives me a negative value, which I approximated on the wording as 1.645 But if you see 448, this 4 would round up to 5. But again, this number is negative, so I am going to make it positive. In other words, I really just want the positive result, so I take the absolute value. We haven't talked about the absolute value function yet. It's a canned function. It's built into Excel, and we just use ABS for absolute value. So that equals the ABS, open parenthesis, click on the cell with z sub alpha over 2 that's negative, close my parenthesis and press enter, and you'll see it just gives me the positive result. Now to find E. The formula is E equals z sub alpha over 2 times the big square root of p hat times q hat over n. Let's go back to spreadsheet and try to type all that in. E equals, first thing we want to do is the z sub alpha over 2 positive. So that will equal, I'll click on the cell reference that contains that, times, now we haven't discussed the square root function yet. Another canned function, it's built into Excel, and it's a pretty simple one. It's just SQRT. We're going to open parentheses. We can just type it in directly. The order of operations in this case is just directly, it just works out. So we don't have to worry too much about putting extra parentheses in or whatever. So this will equal the square root of, let's see, p hat from the formula times q hat divided by the number of values that we have. I will close my parenthesis and press enter. And as you can see, it's that number that I had on the spreadsheet, 0.0644. Now for the easy part. On the left side, what we do is we take p hat and we just subtract this E value. So equals the cell that contains p hat minus the cell that contains E, and that's on the left side. And as you can see, that's 0.6737. It shows here 0.67366 something, but again, at the 10,000th place, that should be far enough to go. We would round, and in this case, the 6 goes up to a 7. And on this side, we would say equals whatever p hat is plus E, and we get the 0.8025 number. So in other words, this is my confidence interval right here. This means that if I were to go out and get the entire population proportion of those who would find surveys to be untrustworthy at the 90% level of confidence, I can be sure that it will be between 0.6737 and 0.8025.